Good day, everybody, and we are back again after some rest. Okay, and we haven't posted for a while. I hope that you guys are fresh and back on your studies again. I'm sure some of you are still continuing to write those prelims. So I just thought, for those of you who have just written prelims on physical science, I'm just going to take the Gauteng paper and probably some of the other provinces, and I'm going to just help you diagnose, some of those challenges that you had. So yeah, if you haven't subscribed, please just be part of the family. Just make sure that you hit that subscribe button. And by the way, for those of you who still want help with either mathematics or physical science, you can send me an email. Okay, the email is info@mlungisinkosi.co.za. All right, let's quickly get into it. I'm going to start with question 2 that had to do with Newton's second law, right? Okay, and they say an empty lift is supported by steel cable. The lift moves upwards rather at a constant speed. So that should be something that you should have highlighted, the fact that it's moving at a constant speed. Okay, remember, if it's moving at a constant speed, it means that acceleration is zero, right? There is no acceleration in that case. Okay, so they say while an upward force of 2,500 newtons is applied by the cable, right? They say ignore the mass of the cable and all frictional forces. Now, say state Newton's second law of motion in words. Of course, I know you should know that law by now. Okay, there are two ways of stating it. If a resultant force acts on a body, the body will accelerate in the direction of the resultant force, and that acceleration directly proportional to the force and inversely proportional to the mass of the object. Or you can just simply say resultant force is directly proportional to the rate of change of a body's momentum. Okay, all right, now they say draw a labeled free body diagram. Now remember, we had that lift and it was lifted by a steel cable, right? So in this case, what are the forces that would be acting? Of course, we'd have a force upwards. Okay, this would be the force, you can say the force of the cable. Okay, and you can also have the gravitational force. Remember, as you're lifting it, remember the earth is pulling it towards its center, right? So in this case, we know we're going to have either the force of gravity, you can call it force of gravity, or you can just simply call it the weight, whichever one you prefer, right? Okay, so next question. Okay, and by the way, it's 2 marks, so it's telling you, there were only two forces. And by the way, I've also just made an indication of it by simply showing you the magnitude of those forces should be equal. Why is that? Because remember, acceleration is zero, so these forces, these two forces are balanced, right? Okay, now they say to you write down the magnitude. You see, they are not asking you to calculate it. They're saying write down the magnitude of the acceleration of the lift as it moves upwards. So we know in that case for 2.3, the acceleration will definitely be 0 meters per second squared. Remember, this was 2.2, right? Okay, and then they say to you calculate the mass of the empty lift. Okay, so in 2.4, I want the mass of the lift, so I know that F net is equal to MA, right? So, but what are the two forces that are acting? It's going to be the force of the cable. Okay, I'm going to take my upwards motion as positive. So force of the cable minus force of gravity. This is equal to MA, but I know that acceleration is 0, so this will be equal to 0. So I know that it means the force of the cable must be equal to the force of gravity when I take it to the other side. So this is equal to mg, which is force of gravity. This was 2,500. I want the mass, and I know gravitational acceleration is 9.8, right? So all I need to do, just divide 2,500 by 9.8, and I get 255.1. So the mass is 255.1, and remember this is mass, so it's in kilograms. Okay, right, beautiful stuff. That was the mass of the lift. Okay, they say when the 2500 Newton force on the cable is replaced by a by force of 3000 newtons, the lift accelerates upwards. Okay, this makes sense. Remember, the mass will stay the same, and so the force of gravity will remain the same. So if you increase the force that was acting on the cable, what happens? It means that your resultant force now, remember, the bigger force now becomes the force of the cable. So it means your resultant force is upwards, and so remember, body will accelerate in the direction of that resultant force, right? So if you don't mind, I'm just going to cover this up. Okay, I know that you already have that answer, so I'm just going to continue over to this side. Okay, so now we know we know the forces that are acting, right? We know that it's still going to be the force of the cable, but now the force of the cable is larger. Okay, sorry, I just need to adjust that a bit. Okay, so the force of the cable is much larger than the gravitational force. And please, just something to note when you are drawing that free body diagram. Please just make sure that your dot actually is connected to, your lines there. Okay, so what I'm trying to say is that don't draw a dot and with a line that's like that, that's disconnected. You lose marks when you do that. Okay, just make sure it is absolutely connected to that dot. And then secondly, please just indicate your arrows. Okay, learners have you have a tendency of just drawing the free body diagram without those arrows. Just please remember to draw those arrows just to indicate direction. Okay, so now we know the force of the cable is actually 3000 again, so we're going to say F net, or you can say F resultant is equal to MA, right? So that's going to be force of the cable. I'm still going to take that direction upwards as positive, okay, minus the force of gravity. This is equal to MA. Definitely there's an acceleration this time around, so this is going to be 3000 minus, now if you remember that gravitational force initially was 2500. Okay, you can say MA, but I mean, remember it gave us that 2500. It still remains the same, so it means my force of gravity would be 2500. Okay, remember my mass, that's the one we calculated over there, that's 255.1. Okay, so this is going to be 255.1 multiplied by the acceleration. Okay, so all we need to do now, okay, is say, so we know 3000 minus that 2500. Remember, we took up as positive, so that's why our force of gravity was negative there. Okay, so I'm going to say 500 divided by 255.1. Okay, and I get an acceleration of 1.996. So our acceleration is 1.96 meters per second squared. Okay, right, and then they say that's the final question. So this was 2.5, and then the final question is identify the force, the forms of Newton 3 force pair with the weight of the empty lift. Okay, so they want, remember that Newton 3 is an action reaction law, right? So if you state Newton's third law in one of the ways, it says if body A exerts a force on body B, then body B will exert an equal but opposite force on body A, right? So they said you must identify a force that forms Newton's third law force pair. Okay, so remember, if A on B, then B on A, right? Now they want which force forms a Newton an action reaction pair with the weight. Now we need to first establish what is weight. Weight is the force that the earth exerts on an object. Remember, the earth is pulling you towards its center, right? So therefore, it's earth on body, right? So therefore, what would be the action reaction pair? So if A on B, then B on A, right? The action reaction pair would be B on A. So in this case, it's the earth on the body, right? So in this case, what's the action reaction pair? It's going to be the body on the earth, right? So that would be the action reaction pair. So the action reaction pair for the weight in that case would be the force that the lift exerts on the earth. Okay, right. Remember, they're pulling each other with forces that are equal but opposite. All right. So that is how the Gauteng cookie crumbles on question 2. We're going to take another one another time. Okay, otherwise, I will see you guys next time. I know that you probably enjoyed this one, and I'm sure you got full marks as well, right? Okay, see you again next time. All right. Sharp, sharp.